Hello friends, welcome to my channel. In this video, we shall learn about units and dimension related to physical quantity in physics and also about dimensional formula related to Gpstr exams, TET, central TET exams from physics. Okay, so before moving to the concept, I thank all my subscribers for your support. And if you're watching this video and if you're new to the channel, please do subscribe and press the bell icon so that you will get the notifications of all the videos we upload here related to Gpstr exams, physics, maths concepts, mental ability concepts, and also mainly solutions for question paper for Gpstr exams related. Okay, come, let's move into the concept now. Already we have posted a video related to units and measurements in physics. The link is given in the description box. Please check it out. There we already we learned about physical quantities, basics, units, okay, mainly about SI units. In this video we will focus on dimensional formula. So the related things also we will check it out, and hence we will conclude with dimensional formula, okay, which is very important for the competitive exams. Okay, measured physical quantity, any physical quantity, it is expressed in product of numerical value and unit. Okay, in physics measurement is very important. So without measuring, you cannot say just approximation. Measurement is very important. So it's a process of comparison of the given physical quantity with the unknown standard quantity of the same nature. We just compare the quantity in measurement. And speaking about the unit is a quantity of a constant magnitude, okay, of which it is used to measure the magnitude of other quantity of the same nature. Okay, so this top definitions won't be asked to derive what it is, just to know what it is, unit. Okay, for example, suppose if we take a physical quantity mass, we express like this: 10 kg of a substance of mass. Okay, what it is, 10 is a numerical value, kg is a unit of mass. When we express that in case of weight is equal to 5 Newton, we say. So weight is a physical quantity, 5 is a numerical value, and n is a unit. So physical quantity is expressed in the product of numerical value and unit. Same for force also. Okay, force is equal to 40 Newton, 50 Newton, any numerical value it could be. And moving to unit, these units are divided into two types: fundamental or basic units and derived units. Okay, what are fundamental units now? These fundamental units are the basic units which tell us that it is independent of any other unit, okay, which can neither be changed nor it could be related to any other fundamental units. It is independent. Okay, for example, unit of mass, it is independent. What is the unit, SI unit of mass? It is kg, we write. So it is independent. For length, meter, we say. Time, second. Temperature, Kelvin. Current, ampere. For amount of substance, we say mole of a substance. So these are like independent of each other. So these are fundamental quantities, and fundamental units are kg. For here, for length, meter, and we have second for time. Okay, here it should be meter. Okay, meter. For time it is second, temperature Kelvin, and it follows like this. And here candela is a unit of luminous intensity. Okay, how bright the object is, for stars and all, to calculate the brightness. Okay, luminous intensity. Then moving to derived units, these units are other than the fundamental units, which can be related to the fundamental units. For example, when we write area of a square, let us take here, If you consider this is length and this is also length, usually we say length and breadth. For this length and the side length, so length into length gives us length square, or we can call it as length into breadth also. For volume, we write length into length into length, L cube, or m into m into m, that is the unit. SI unit of length is meter, so m cube is the unit of volume, length into breadth into height. And for area it is m square, and m cube is the unit of volume. Cleared? So here there are few examples of physical quantities, how we express them in terms of derived units. Okay, these are the examples for derived units. All this, how do we derive this? Density is a physical quantity. Density, what is the formula? Mass by volume. SI unit of mass is kg. For volume, meter cube. So when you take this meter cube to the numerator, it becomes 10 to the power, m to the power of minus 3. So kg per meter cube. This is how to read that. For acceleration, about acceleration and all we have already learned in the previous class. The link is given in the description box. Even you can check out in the playlist, physics playlist. You will get all this explanation for this. We have discussed about force, acceleration, speed and all. Please check out the description box and playlist of our channel. So acceleration is nothing but velocity by time taken. Okay, and again velocity can be written as meter per second, and this meter per second, when you take to the numerator, already we have meter per second as it is, you write s by 1 become 1 by s. That's how any denominator with a single term like this, we find single unit, single number, when it goes to the numerator it changes as 1 by s. Okay, and multiplying 1 into m, s into s square. Again you take this s to the numerator, meter per second square. Okay, it becomes minus. So meter per second square is the derived unit of acceleration. So we are deriving this meter per second square from many other basic fundamental units. Okay, moving to the next one, force. Force is a product of mass and acceleration. Force is equal to m into a. SI unit of mass is kg. For acceleration, just now we have learnt, that is meter per second square. You can write that. Then write them together. Kg meter per second square is the unit of force. So this is a unit which you have derived. Okay, and this is also SI unit. Don't get confused with SI units, basic fundamental units and derived units. Okay, derived units are like this, many basic units you put together are derived from the fundamental units. Okay, and SI unit of Newton is SI unit of force is Newton. So 1 Newton is equal to 1 kg 1 meter per second square. We can also express Newton in this way. For pressure, pressure is equal to force by area. So force, just now we have learnt for force, unit of force kg meter per second square divided by, for area it is m square. Taking this m square to the numerator, it becomes m to the power of minus 2. So here m to the power of 1, if nothing is given, it is understood the power is 1. Any term, if they write x to the power of 1, it is understood. If they write m to the power of 1, okay, 1 time it is. So here there is already 1 m, 1 minus 2, it gives us minus 1. We cannot subtract 1 minus 2, so do 2 minus 1 and put the greater number sign. Especially biology students, when you express this, please check it out with this. Okay, so we can write kg m to the power of minus 1 and second to the power of minus 2. So kg per meter per second square is the unit of pressure. It also can be written as, you just look into this, kg meter per second square of 1 Newton. Okay, per meter square. This is again we have Newton per meter square also we write, or Pascal. SI unit of pressure is Pascal. Okay, this unit could be expressed in this way. Moving to resistance. Resistance is equal to potential difference by current, potential by current. This we get from Ohm's law. Okay, V is equal to IR. So make R subject to the formula V by I. So it is V by I. Potential, we have the unit for potential is here. You can just substitute the formula for potential and just check it out with this. We have already taught about potential, learnt about potential difference and all in the previous class in the current electricity chapter. Check for the description. And this is the unit divided by SI unit of current is ampere. Okay, taking this ampere to the numerator, already you have a to the power of -1. So moving to this, -1 and -1 gives us -2. So a to the power of -2. So remaining and all remains as it is. Kg meter square, ampere to the power of -2, second to the power of -3, or SI unit of resistance is ohm, or this could be written as resistance is equal to volt by ampere also you can write. Cleared? Now let us learn how to write the dimensional formula for the given physical quantity. Okay, very easy. You can learn within few minutes only if you know the basic concepts of physics. Okay, so usually this dimensional formula are expressed in a square bracket, and we take these three letters. I'll tell you what it stands for. Okay, before this I'll explain you these quantities and then we'll go back. Length is expressed as capital letter L. For mass, M, capital letter it should be. For time it is T. Temperature, K. Electric current or generally current, A, ampere. Luminous intensity, CD, candela we say. Amount of substance, mole. So these are the symbols, and you see up to here it is capital and these two are small letters used. So we have to express the dimensional formula in the square bracket, and usually we go for this three letters only. Thereafter if it is additionally added, then we can add this and all if for any unit if you need to calculate. Okay, we'll go to the examples now, then you will understand in a better way. You see, for area, what is the unit formula for area? Length into breadth. Area is length into breadth. Unit of area is meter square. Usually when I say unit here, we speak about SI units only. Okay, SI unit. We don't go for the smaller units. We just apply SI units here. So length is expressed in meter when we measure length of an object. Suppose you have an object like this. If this is the length and this is the breadth, length into breadth is the formula. So how do we measure this length? It's in meter. Even though it is breadth, this is nothing but a length of this particular part. So we measure by meter. So this is also measured in meter, meter into meter, meter square. So here for this particular area we have only the unit for meter, that is for length only. This quantity have only length. So we express in the bracket M. Check it out whether this is having the unit of mass. No. If there is no unit of mass, M to the power of 0 you write. If it is for L, L stands for length. Is it having unit for length? Yes, meter is the unit of length, so power is 2. So that power you have to write here, 2. For T, time, is it having any unit of time, second? No. If it is not there, put 0. Don't get confused with M for mass or T for temperature. No. Here you have to, meanwhile, in the subconscious mind always we have to be conscious about this MLT. M for mass, L for length and T for time, but unit of mass and unit of length and unit of time we have to write to the power. Clear? This is how to write dimensional formula. One more. We shall move to the acceleration. Acceleration formula is velocity by time taken. SI unit of velocity is meter per second divided by, for time, SI unit of time is second. When you take this s to the numerator, it becomes -1. Again -1 and -1 becomes -2. So you will get meter per second square. Here we have meter and second square. Just put in the bracket MLT right first. Okay, MLT right first. Then meter, you check it out for this formula. Meter means it is nothing but length to the power of 1. If nothing is given, 1, so it is 1. For s is for second, s to the power of -2. Second is for time, so -2. So nothing is given as kg, so this m to the power of 0. So you will get m0, m to the power of 0, l to the power of 1, t to the power of -2. This is the dimensional formula for acceleration. For momentum of an object, okay, it is expressed in mass in velocity, product of mass and velocity. So SI unit of mass is kg, for velocity meter per second, we know. So it is, SI unit is kg meter per second. Just immediately when you get this formula, you can just write MLT. Later we'll go for, if they is given about temperature, then you write for K. If you are dealing with something with current, then write A. Okay. If not, if you are dealing only with this formula, you write. So MLT kg. Kg is the SI unit of mass. So mass to the power 1. Kg to the power 1. M for length, that is meter, for length 1. Second for time, second to the power of -1. So t to the power of -1. M to the power of 1, L to the power of 1, t to the power of -1. Or you can plainly write ML t to the power of -1. This is also right. If you don't write the power of 1, it is same as just m. Okay, but you should not write 0. It changes the complete meaning. Okay. Okay, just a reminder for you. If you have not yet subscribed to our channel, please do subscribe and support us. And check for our playlist of maths and physics along with mental ability. You will find some references related to Gpstr exams. Okay. Let us learn for force now. Force is the product of mass and acceleration. So mass into acceleration. SI unit of force is kg. For acceleration, just now we learned meter per second square. So how do we write MLT? This is 3 terms only, nothing to deal with current or temperature. So just write MLT. Kg for mass to the power of 1. M for meter, length to the power of 1. Second for time, so t to the power of -2. Next for work is equal to force into displacement. So SI unit of force, here we have already learnt for force kg meter per second square, that is for Newton, and displacement is meter. So when you take this to meter to the power of 1, meter to the power of 1 gives us meter to the power of 2. So kg meter square per second square for work. And how do we write this? MLT, right? Kg to the power 1. So mass to the power 1. Meter to the power 2. So length to the power 2. Second to the power -2. So time to the power of -2. Is it easy? Please select some more physical quantity and you can practice. Next, on moving to power. Power is equal to work by time, work done by time taken. Okay, just now we have learned for work is equal to kg meter square per second square divided by, for time it is second. Taking this second to the numerator, already you have -2 here and you have -1. So -2 minus 1 is -3. The remaining terms are all same as it is kg, meter square. This you can rewrite as s to the power of -3. Just write MLT kg to the power, mass to the power 1, meter square, length square, s to the power of -3, t to the power of -3. Easy? Suppose you say that, ma'am, I forgot everything, in an exam tension. So what shall I do? Sitting in the exam hall, I have still some more time to left out to answer this question. Okay, so you can also follow this method. It's a bit a long method. Suppose you forgot the SI units or some particular object in between and the formula is given as a lengthy one. you have to find the dimensional formula. So there is another method, same method elaborated and written. We have to deduct that. Okay, suppose if it is given for pressure, so you know only the formula for pressure, that is force by area. But for force, again you have to expand and write. What's for force? Force is nothing but mass into acceleration divided by area. Write as it is. Again, mass, further we cannot be divide this into the sum product. So mass, write as it is. Acceleration can be written as velocity by time taken divided by area. Again, this velocity can be written as displacement by time. Means again you will write mass as it is, velocity is displacement by time, and divided by this time is remaining, that divided by time you write here, and whole divided by area. This area is carried out. Now all these are basic quantities we got. Now we can get write the SI units for all these basic quantities. So for SI unit of mass is kg, for displacement it is measured in meter, for time second, divided by one more second here, whole divided by, for area, meter square. Now we have to solve this upper part, okay, numerator part. So kg into meter per second into, when this second goes to the numerator, it becomes 1 by s, 1 by second, whole divided by meter square. Be careful while solving this. Then on simplifying this, only numerator, kg write as it is, meter into 1 gives us meter, divided by s into s square. Only numerator we have solved, divided by this meter square carries as it is. Now take this meter square to the numerator. Meter square becomes, it is understood that when it is simply we write some numeral or any number like this, it's understood, divided by 1 we have. So when you take to the numerator, it becomes reverse of that. Okay, this factor will be there, kg meter by second square into 1 by meter square. 1 meter and meter square, here 2 m are there, 1 m get cancelled, so m remains. At last on solving, on getting the answer, we get kg into 1 kg. In the denominator we have m to the power of 1, so taking to the numerator m to the power of minus 1. This s to the power of 2 goes to numerator, it changes as s to the power of minus 2. At last we arrived at that. Then just write mLT, kg, mass to the power of 1, meter, length to the power of minus 1, for second, time to the power of minus 2. Okay, hence we got the dimensional formula. So in the exam, if you sit and solve for all this, it will be difficult. Suppose you have time and you can get Paka answers, fine. Otherwise you can just directly substitute for that formula, and you can, if you by heart all the formula, it will be difficult for you. So know the basic concepts and hence you can learn. Fine. Okay, thank you for watching. Thank you for your support. In the following classes we will handle few more concepts of physics and mathematics related to Gpstr exams. Okay, thank you.